Section 2.1.2, Simplifying Radicals. One place that we are sure to run into complex numbers is when we simplify radicals. A radical is simplified when the radicand contains no perfect square factors. Now, just a reminder about the vocabulary here. The radicand is the number under the radical sign. So the square root sign is what we're calling the radical sign, and what's under the radical is the radicand. We're going to look for factors of the radicand that are perfect squares so we can evaluate the square root and simplify the radical. Example 1, simplify each radical exactly or state that it cannot be simplified. Example A, square root of 36, hopefully you're familiar with this one, is 6 because when we square 6, let me show this as a check step in red, when we evaluate 6 squared, which is 6 times 6, we get 36. So the square root of 36 is 6. Now, sometimes it doesn't work out so nicely. Example B, we have the square root of 12. Well, that's not a perfect square. So our goal is to find a perfect square factor of 12, reduce it, and thus simplify the radical. So I'm going to think of the factors of 12, and I'm specifically looking for one that's a perfect square. We can think of the square root of 12 as the square root of 3 times 4. Now, the reason I use 3 times 4 is because 4 is a perfect square factor of 12. Now, one of the properties of radicals says that if you're taking the square root of a product, you can evaluate that as the product of the square roots of the individual factors. So in the case of the square root of 12, I can rewrite this as square root of 3 times the square root of 4. The square root of 3 is not a perfect square, so it will not simplify, but 4 is a perfect square, and its square root is 2. So we have simplified the square root of 12 as the square root of 3 times 2. However, in general, we write the whole number on the left side of the radical, and we leave the irrational part on the right side. So we'd say the square root of 12 is 2 square root of 3. In example C, we're looking at the square root of 15. Notice that 15 does not have any factors that are perfect squares. 15 can be evaluated as 3 times 5. Both of those are not perfect squares, so there's nothing we can do to simplify the square root of 15. We'll leave it as the square root of 15. On example D, we're reviewing how do you find the square root of a fraction. Like the product rule that I mentioned above, to find the square root of a quotient, we can split that radical over the numerator and denominator and evaluate those radicals individually. So the square root of 25 over 16 would be evaluated as the square root of 25 over the square root of 16. Both of those are perfect squares, so they're very simple to evaluate. Square root of 25 is 5, and the square root of 16 is 4. Now, make sure that you know where to locate that square root button on your calculator. It's over there on the left side of your keypad in blue above the x squared button. So to evaluate the square root of 36, I would type in my second button, and then I would type the x squared button, which accesses the radical, enter the radicand 36, and press enter. And we can verify our values. Now, if we try to evaluate something like square root of 12, which is not a perfect square, the calculator is going to approximate the irrational number. Square root of 12 is actually a non-terminating, non-repeating decimal, but our calculator is going to approximate it with several decimal places. So we get approximately 3.46. Now, the answer that we ended up with is exact. We got 2 square root of 3. To see if we simplified correctly, I'm going to type in my reduced answer, 2 square root of 3, and notice the decimal values are the same. So we know that 2 square root of 3 is the correct simplification of square root of 12. I'm going to type in example D, square root of 25 over 16. We're going to enter the fraction just using that division button. And when we press enter, the calculator returns a terminating decimal. That means it is a decimal that stops or can be written as a fraction. So let's convert it back to a fraction with our math button, and we can see that we've correctly evaluated that square root. Now, the next set of examples, notice all the radicands are negative. If we have a negative radicand, we're going to end up with an imaginary square root. So we have already determined that the square root of 36 is 6. Let's look at how we're going to evaluate the square root of negative 36. Now, let's think of negative 36 as 36 times negative 1. So I'm just going to rewrite our radical, 36 times negative 1. Using our rule for the square root of a product, we can write that as square root of 36 times the square root of negative 1. Square root of 36 is 6, and remember we defined the imaginary unit I to represent the square root of negative 1. So the square root of negative 36 is 6i. Anytime we have a negative under a radical, we're going to end up with an I in simplifying that radical. Now, to check this, let's notice we're going to have 6i squared, and we can rewrite that as 6 squared times I squared. 6 squared is obviously 36, and if you'll remember from our definition above, I squared is equal to negative 1. So I squared gets replaced with negative 1, and 36 times negative 1 is 36. So notice we have squared a negative number. We have squared an imaginary number, and it yields a negative number. Only imaginary or complex numbers do that. Real numbers do not do that. So the square root of negative 36 is 6i. Again, anytime you have a negative under the radical, the result is going to have an I when we simplify. So we'll take a little bit of a shortcut on the next one. Instead of rewriting that as 18 times negative 1, we're going to recognize the negative under the radical can be represented as an I, and then we'll focus on simplifying the square root of 18. Now, 18 does have a factor that's a perfect square. So I'm going to think of the square root of 18 as 9 times 2. The square root of 9 is 3. Let me split up my radical here. The square root of 9 is 3. And the square root of 2 cannot be simplified. Okay, now let's put it all together in a readable form. When we write the combination of a radical and I, we want the whole number to the left. We're going to put the I in the middle, and the square root of 2 goes on the right. So the square root of negative 18 is 3i square root of 2. Let's try the next example. Square root of negative 150. Because we have a negative under the radical, we're going to extract it as an I, and then focus on simplifying square root of 150. So I need to think of a factor of 150 that is a perfect square. And I'm going to look at 150 and think of it as $1.50. I know that $1.50 can be made up of quarters, right? How many quarters in $1.50? Looks like we get 6 quarters in $1.50, right? So I know that 150 is 25 times 6. And of course, you could bust out your calculator and do a little trial and error to test out factors of 150. Splitting up our radical, we have I square root of 25 times the square root of 6, or I times 5 times the square root of 6. And then putting it together in that standard order, we have 5i square root of 6. So the square root of negative 150 is 5i square root of 6. Let's simplify this last one, and then we'll go back and talk about checking this with our calculator. So first of all, we're going to split the radical up over the numerator and the denominator. Then we can extract the I from the numerator. So we have I square root of 13 in the numerator. And the denominator we can simplify. The square root of 9 is 3. Now because 13 is prime, square root of 13 is completely simplified. So remember, if you have a negative under the radical, it's going to be represented as an I in your final answer. The good news is you can certainly check all of this with your calculator. So let's refer to the calculator and see what happens when we type in square root of negative 36. So I'm going to do second and then square root. Make sure you use the little negative sign at the bottom of the keypad, not the minus operation. Now, when we type in square root of negative 36, notice what the calculator says. It returns error, non-real answer. Well, that's true. The square root of negative 36 is not real, it's imaginary. So I want to show you how to give your calculator access to that larger set of numbers, the complex numbers. So type your mode key up there next to your second key, and then use your arrows to go down to the line that begins with real. Right now the calculator is using real numbers only. I'm going to use the right arrow key to highlight A plus BI. You'll recognize that as the standard form of a complex number. Now press enter to actually change the mode to complex mode, and then we can go back to our home screen by pressing second followed by quit. Now I'm going to re-enter square root of negative 36, and now the calculator tells me 6i. That's awesome. We can check even the square root of a negative number with our calculator. Now also at this time, I want to show you, if you'll remember, we checked this by squaring 6i. So I'm going to also type that into my calculator. Now I'm going to open parentheses and I'm going to enter 6i. Notice down above your decimal key, you'll see a little I in blue. So to access the I press first my second key and then the I, close parentheses, and square the result. And it squares 6i to give us negative 36. Now, even if our answer doesn't come out as neatly as it did on example E, we can still check problems like square root of negative 18 on example F. So let's enter the original problem, square root of negative 18. The calculator gives me the decimal approximation of that irrational number, but I can see on the end there it's imaginary. There's an I associated with it. Our answer was 3i square root of 2. So I'm going to type in our answer, 3i second square root of 2, and compare the decimals. The decimals are the same, they both have an I, so that gives me confidence that our evaluation is correct. Make sure when you evaluate square root of negative 18 on your homework that you do not give the decimal approximation. Give the exact value, which is 3i square root of 2. But remember, you can check it with your calculator. So let's verify square root of negative 150. That's the original problem. We ended up with 5i square root of 6, and the decimals are the same. Finally, we can check square root of negative 13 over 9. The calculator gives us the decimal approximation. We can enter our answer, I square root of 13. Now, at this point, after I enter the square root of 13, I'm going to use my right arrow key to get out of that radical before I divide by 3. And the decimals match, so we have done it correctly. I strongly recommend you practicing with your calculator so that you'll know how to appropriately type these in. Now, we are studying this in preparation for solving quadratic equations. One method that we're going to learn to solve quadratic equations is the quadratic formula. You may already be familiar with the quadratic formula. Sometimes the result of a quadratic formula looks something like this, and we're going to need to be able to simplify that using our radical simplification skills. If we have something that looks like this, the first thing we want to do is simplify the radical. Then we're going to split it up into two separate fractions, and then we will reduce the fractions in that order. So let's start working on just this part. I'm going to pull that out and kind of work this as an individual problem. So let's figure out the square root of negative 24. Because there's a negative under the radical, we're going to pull that out as an I, and then we're going to simplify square root of 24. So I want to think of a factor of 24 that is a perfect square. The pair 4 times 6 would work perfectly. So split my radical up over each of those factors, and we have I times 2 times square root of 6. Notice the factors of 6 are 2 times 3. Neither of those is a perfect square, so that radical is simplified. We'll rearrange the order to get 2I square root of 6. So now, square root of negative 24, we figured out, is 2I square root of 6. Let's go back to the original problem now. Replacing negative or square root of negative 24 with 2I square root of 6 brings us to step 2. We've simplified the radical. Now we want to separate the fractions. Make sure that you separate the fractions. Do not cancel those 2's. Your eye may have gone that direction until you separate the fraction. So each term in the numerator has to be divided by the denominator. I want to cancel uniformly, not with just part of that sum in the numerator. Now, negative 6 divided by 2 is negative 3. Now it's legal to cancel those 2's, and we get minus I square root of 6. Notice this is in the form A plus BI. The real part is first, the imaginary part is second. Even this type of problem can be verified with your calculator, but we do have to be careful about how we plug it in. I've mentioned before that if your fraction has either an operation in the numerator or the denominator, that you need to enclose that in a set of parentheses before you type it into your calculator. And that's going to be true here as well. So let's plug in our original problem, and we'll compare it to our answer. So I'm going to open parentheses and evaluate negative 6 minus, notice I use the little negative button for the negative sign and the minus operation for the subtraction there. Square root negative 24. Now I'm going to use my right arrow key to get out of that radical, close parentheses, and divide by 2. We're going to get a standard form complex number, negative 3 minus approximately 2.4i. The negative 3 matches our real part. We just want to check on the imaginary part. So now I'm going to plug in our answer, negative 3 minus second I second square root of 6, and evaluate. Since both parts match, we have correctly simplified that expression. Let's try one more example, and I want to remind you that we're doing this in preparation for solving quadratic equations. This is the type of solution we're going to get out of the quadratic formula in some cases, so this is going to be the end of a bigger problem that's to come. So we're getting all these details straightened out. Let's work on the radical part first. We can think of the square root of 32 as the square root of 16 times 2. 16 is a perfect square, so we can reduce that as 4 square root of 2. So now that we've taken care of that little small part of this evaluation, we can replace the square root of 32 with 4 square root of 2, and then divide the whole thing by 6. To correctly simplify, every term in the numerator gets placed over that denominator, and then we can reduce. Notice the common factor of 2. 2 divided by 2 is 1, 6 divided by 2 is 3, and in our second fraction, 4 divided by 2 is 2, and 6 divided by 2 is 3. Now, I cannot simplify or cancel the 2 under the radical with an ordinary 2. That 2 under the radical stays under the radical as is. So our result here is 1/3 plus 2 square root of 2 over 3. It did not turn out to be imaginary in this case because our radical was over a positive number. But let's check it for good measure, okay? So remember, when we enter this into our calculator, because we've got an operation in the numerator, we're going to need that set of parentheses around the numerator. So I'm going to type in 2 plus second square root of 32. I'll use my right arrow key to get out of that radical and divide by 6. So this is the decimal approximation of that irrational number. Let's compare it to our result. We have 1/3 plus 2 second square root of 2. Again, use your right arrow key to get out of that radical and divide by 3. Awesome. When you see that, you're confident that you have done it correctly. And we can verify that is the correct simplification. Now remember, this is an important skill later when we solve quadratic equations. This is going to be the end of the problem. This is how we will simplify our answers soon to come.